Hi, in this video, we're going to look at TCP and UDP port numbers. So a single client may have multiple transport connections with multiple servers or even the same server. So here we have a single client connecting with multiple servers, HTTP, FTTP, SMTP. Any host on the network can have multiple applications that are communicating simultaneously. It's the responsibility of the transport layer to maintain these multiple communication streams between all these applications. Okay, and this is all done with port numbers. Okay, port numbers are assigned by IANA, Internet Assigned Numbers Authority. And you can go to their webpage and take a look at all the well-known port numbers. We'll learn what well-known port numbers are in a moment, and other port numbers as well. Port numbers range from 0 to 65,535. That's because there's 16 bits allocated in both the TCP and UDP headers for port numbers. We can see there's both source and destination port numbers. We'll see that in a moment. There are three categories of port numbers. Well-known port numbers range from 0 to 1023. Registered port numbers, 1024 to 49151. And private or dynamic port numbers, 49152 to 65535. Okay, as you can see in both the UDP and TCP header, they both contain port numbers, both source port numbers and destination port numbers. Okay, that they're used to identify the application or service that's involved, both at the client end and the destination, the client and the server end. Okay, both TCP and UDP use these ports known as sockets, and we'll talk about what a socket is in the upcoming video, to pass on information to the upper layers. Okay, for example, you see port numbers there like 21 for FTP, 53 for DNS, port 80 for HTTP. All right, let's take an example of what this looks like. So here we have a client accessing a web page. Okay, so the source port will be used that says this is the application the segment came from. This is, we'll see in a moment, is dynamically assigned by the client and says, for me, this is the process, the application, the window that I'm assigning this port number to. The destination port number is where this is going to on the server. We'll see how this works in just a moment. It's typically a well-known port number like port 80 HTTP. Coming back, okay, the source port, this is the application that the segment came from. So that's actually from the server's point of view. And the destination port is the application the segment is going to. Sound a little confusing? Hang on, we're gonna rectify that in just a moment. Okay, so as far as encapsulation, port numbers are used by the sender to tell the receiver which application it should use for the data. Decapsulation, port numbers are used by the receiver so it knows which application it should send the data to. This is all going to come together in a moment. Let's take a look at the three types of port numbers, and then we're going to bring this all together. Well-known port numbers are from 0 to 1023. These are reserved for common services and applications, many that you see there, like FTP port 21, HTTP port 80, port 443, secure HTTP. Okay. On the client side, it's going to use this as its destination port. This is typical because the client is wanting to connect with a server that offers one of these services like HTTP. Okay, so it's usually a well-known port is a destination port coming from the client. This segment is destined for port 80, HTTP, for example. On the server side, it's the source port. So if the server, in this case, let's say an HTTP, a web server, is responding to a client's request, it's coming from its source port, port 80, HTTP. Okay, registered ports. Registered ports are from 1024 to 49151. Okay, they're they're non-common applications. Okay, a lot of vendor applications use these port numbers. Now, I'll also well, let me kind of continue here. So similar to well-known port numbers, a client would use this as a destination port if it was wanting to reach, let's say, MSN Messenger or Radius or something like that on the server. And the server would respond with that register port as its source port for one of these services. Now, that said, you'll also see some operating systems use these numbers from 1024 to 49151 as their dynamic or private ports, which we're going to talk about next. So dynamic or private ports, these are known as ethereal ports, usually assigned dynamically by the client's application when initiating a connection. Okay, the client will use this as its source port. Okay, for example, if this device here, and we're going to see more examples coming up, wanted to connect to, say, a HTTP web server, okay, the destination port would be port 80, the well-known port. But its source port, it's going to say, oh, I'm going to assign this dynamically. I'm going to do this myself from one of these dynamic or private port numbers. Now, as I mentioned earlier, it could also be it could also use a register port number. So it's not uncommon to see these source port numbers originating from the client, allocated by the client dynamically, starting at 1024. Okay. And when the server responds, it's going to respond to a destination port that is the same as the source port on the client. Let's bring this all together here. All right, so let's say the client is communicating with this web server. Okay, so the client is going to do an HTTP GET. Okay, client sends a TCP segment with the destination port, port 80. Okay, because it's wanting to communicate with this web server using HTTP port 80. It dynamically, the client does this internally by itself. Says, okay, I'm gonna, for this this browser window here, I'm gonna assign port 1028. We'll see how this is used more in a moment, okay? But since it'll be port 1028 on my end, okay? Now, when the server responds, okay, the server is gonna respond to the client, says, oh, when I send you information, I'll make sure I send it to your destination. It's going to be my destination port, 1028. So you know which port to apply it to when you receive it. I got that 1028 from you, client, when you initiated the connection. And it's coming from my port 80. Okay, this is an HTTP response of some sort. Okay, so I'm sending you some information. Okay. So we can kind of see how these relate. Okay, on the client end, the destination port will be typically a well-known port number like port 80, requesting access to the HTTP service on the web server. From the server's end, you see that port 80 is a source port. It's coming from its HTTP service. The source port on the client end is created dynamically. It assigns it. So it knows which port that it's going to allocate, reserve for this specific application. When the server responds to the client, it will respond using the destination port received by the client, allocated by the client, in this case, 1028. Okay, so let's take a look here. Here we have a client that's going to connect to the server, but actually going to have two different windows open. We can do this, right? You can go to cisco.com and open up two tabs or even two windows. Doesn't matter. Okay. So let's say this client is using the source port number 49888, that one that it allocated. And it's using destination port number 80, of course, the well-known port number for HTTP. The server responds, okay, from its source port, port 80, in blue there, That's where it's coming from, its HTTP service, and destined for 49888, the client's original source port of the client, the destination port used by the server. Now let's say the client opens up another session to this same Cisco web page. Okay, the operating system allocates, in this case, port number 49890. So that will be the source port, okay, destined for port 80. Okay, coming back from the server, it comes back from its port 80, but this time, anything done in this browser, in this window specifically, it will be destined for 49890. Okay, so the client, same destination port numbers, port 80, it's the web service, okay, but different source ports to uniquely identify this web session. Now, I want to mention that HTTP and HTTPS typically allocate multiple port numbers per web session. So when you're on a web page, you don't have just one port number. Typically, you will have different port numbers for different types of objects, for HTML, JPEGs, banner ads, or whatever it might be. So you'll see several port numbers associated typically with one web page. All right, you know what? We can look at this using a command that you can use it on Linux, Windows, and Mac OS, Netstat. And I'm using Netstat -n to show the numbers. Okay, and this is kind of cool. Okay, so we can actually, whoops, let me back up here. Sorry about that. So we'll take a look at this more in a moment, but we can see it's using TCP as the protocol. The local address, this is the IP address of the client and the source port of the client. This is the destination IP address and the destination port. By the way, these are known as sockets. We're going to look at these later in the next video. Okay, source IP address and source port, destination IP address and destination port are known as sockets. Okay, if you want to learn more about the Netstat command, depending upon your operating system, you just can look at the help feature. Okay, you can see all kinds of information is available with Netstat. Very cool command. Okay. And here we can actually see the, using Wireshark, we can see those source ports and destination ports on this example. It looks like it's using a source port 63533 and destination port 80. Yeah, you can see in the data there, right? Hypertext Transfer Protocol, okay? All right, here we see the reply. Source port 80, destination 63533. Okay. All right, more about TCP, UDP, and even more about port numbers in later videos.